2018 Ford F-350 Super Duty. Issue with this one is the headlights, you can see them there, always stay on. HVAC controls don't work. Sometimes they do, sometimes they don't. They light up, but there's no fan control. So in the wintertime in Idaho, it gets pretty cold. And the radio don't work. And the front windows don't work. Once in a while they will, but most of the time they don't. So I'm doing a full system scan. I'm using my Topology here. I'm just going to scan all modules. I'm going to let that scan for a minute. Alright, so if you can see here, there's some codes. Well, it's still scanning. But what we're doing here, everything goes through the GWM, or the gateway module. Don't Google GWM because it comes up as a gay white male. But it's actually GWM's gateway module. So the gateway module on these Fords is this guy down here where the DLC connector is. That's the little gateway module. Which means for all of these, like you got high-speed CAN 1, high-speed CAN 2, high-speed CAN 3, for your engine, ABS, airbag stuff, and you got medium-speed CAN 1 and medium-speed CAN 2 for like your door locks, windows, HVAC, less important stuff. That gateway module has to talk, all these guys have to go through the gateway module to talk, through to the DLC. 6 and 14 is high-speed CAN 1, CAN high, CAN low, and 3 and 11 is high-speed CAN 2, CAN high, CAN low. The other medium-speed cans, you can't draw, you talk to the modules through the gateway module. So, if you go to report, the RCM restraint control module, invalid data received from the front controls interface module, which I believe is this. The FCIM is the HVAC module. APIM, USB thing, don't care about that, that's always been in there. Body control module. Left front position light, right front position light. Those lights keep coming on. Camera module, but what's important is these U codes. U codes are communication codes. Lost comm with body control B, lost comm with door module A, lost comm with door module B, which is the passenger, and lost comm with the front controls interface module, which is that. In other words, not this, what you're finding out here is they're all in the same bus, which is medium speed CAN. And the FCDIM lost comm with the front controls interface module. So these modules here are talking to try to get on this bus. This dark purple here is medium speed CAN 1. If you can see that, that's medium speed CAN 1. MS CAN 1 is the one we're looking at. We don't care about these other ones. I mean, we do, but we're having issues with these. The whole bus ain't done because we got two modules, the trailer module and the global positioning module, talking on this bus. So you can clear these, redo it, same stuff comes back. The lights codes, the two light codes take a little bit to come back. So if I go into the FCIM, which is this guy right there, it'll have a no comm because it's grayed out. No comm, and that's the customer's biggest complaint. So what we're going to do now is look at some schematics.
Go for it, I'll listen.
Alrighty, so now this gateway module here, the gateway module and the DLC. The DLC, diagnostic link connector, we're hooked up as part of the gateway module. So if you want to talk, when you've got your high-speed CAN 1 and your high-speed CAN 2 through those pins, 6, 14, 3, and 11. But the other high-speed CAN 3 and the medium-speed CAN 1 and the medium-speed CAN 2, well, they are going through the gateway module, like I said. So the issue that we're having now with is medium-speed CAN 1, which goes to G and H. Well, from G and H, it goes over to G and H, late production. It's made of April of 18. So it comes in. It doesn't have a heated steering wheel, so that doesn't matter. I cross it out. It's got the global positioning system, which we have comm with. See all these branch lines. It goes over to trailer tow module, which we have comm with. Then it goes down to K and L. K and L, narrow frame or without bliss. That's that blind spot monitoring. I don't believe this has blind spot monitoring. So it's without bliss. It comes down. It branches off to N and M. But it also goes over here for your rear lights, rear tail lights, reversing lights. Which, okay, we do care about it, but I don't right now for this application. So what we're going to go to next is N and M. And an M branches off to T and U and G and F. But before we do that, it goes to the driver door module, no comm, remember from earlier. Radio transmitter, no comm, radio's not working. Power running boards, doesn't have it. It doesn't have heated seats, movable seats, so that doesn't matter. So let's go to T and U and Q and P. Well, first, this one's T and U, doesn't matter. We don't have this driver multi-seat module. We don't have this fancy stuff. So the other one we have that comes from P and Q, it goes down through your front controls interface module, which this module is your heating and blowing thing, auxiliary lamp module. I don't know if it has that, don't care right now. Then you got a test connector, which is behind your glove box, kind of a pain to get at. So this bus right here, or this is the one with manual AC with multi-function display. These colors line up. The little symbol there means it's shielded or a twisted pair, so there's not interference. If you look in service data, one of the term resistors is in the gateway module, 120 ohms. The other term resistor is in this module, 120 ohms. You put them in parallel, you get 60. So that way you don't get interference back on the bus. So that's what we're going to check next. All right, so before we go any farther, use the oscilloscope. I want to go over how this network works, right? So there's a lot of information in here, but what we're looking at, we got high speed CAN, medium speed CAN. Okay, we want medium speed CAN 1. We want to see if it's a terminating module. So the FCIM, if equipped, which it has, is medium speed CAN 1, says yes, so it is a terminating module. If I check that, I should have 120 ohms. Also, the GWM, not the gay white male, but the gateway module, medium speed CAN, is the terminating module. So look, what's in common here is the gateway module has all the termination resistance for all the different CAN networks. High speed CAN 1 terminates, 2 terminates, 3 terminates, medium speed CAN and medium speed CAN 2 terminate, and on each end of the modules, each end of the network, another module terminates. So in our case, for medium speed CAN 1, the door locks, the windows, AC, the radio, it terminates in the gateway module, and it also terminates in the FCIM. So we want to check 120, 120, we should get 60 when they're together. Check that with the battery off. All these other modules it talks about, don't care. But it even says the CAN uses termination resistance. They put two 120 ohm resistors in parallel and you get 60. What does this do? It improves bus message reliability and stabilizing bus voltage. So interference, when your messages are bouncing back and forth, that resistance absorbs those noise. So the gateway module communicates with all controller area networks. The OBD DLC is fitted to the GWM and is direct interface with the scan tool, which we just talked about and showed. There's two modules on the DLC, high-speed CAN 1 and 2, we show in the diagram. These directly communicate to the diagnostic tool. The other one's high-speed CAN 3, medium-speed CAN 1, and medium-speed CAN 2. If it has a trailer package for medium-speed CAN 2, communicate on the network, but not directly through the scan tool, through the GWM, gateway module, which we already talked about. And then, of course, it shows your oscilloscope stuff, which we'll go over here in a minute. If it showed it together, showed it apart. And it shows you down here, message chart. So what we're going to do now is hook up the oscilloscope. Alright, so what I did now, I have to hook up down here. I'm on, holy crap, that's very messed up. I'm on CAN positive for medium speed CAN 1. So I go down here, I'm just back probing off the gateway module. That's where I have to get to. The other lead to ground using the oscilloscope. There's our messages, that's CAN high, which is not correct. It is, but it isn't. The bias voltage should be between 2 and 3, should be 2.5 volts, meaning don't do nothing, it's idle state. Well look, the bias voltage is below 2. That's incorrect. These are your zeros and one packets of information. Still no comm, this thing isn't turning on. Once in a while it will. But that is incorrect, and once in a while you'll see in there, I don't know if I caught it, but there'll be dead spots in that bus message. What concerns me here is it's not the bias voltage of 2.5 volts. It's a half a volt off. And it's changing. It'll like shift up and down. And we got a battery maintainer on, maintaining battery voltage at 13.5, 14 volts. If I can catch it again. Yeah, right there. That message there is not even going to ground. That's hash. That's not good. So that's another anomaly in here. That's can high. We're going to go to can low, which is going to be a mirror image of it. So I'm going to get my other scope lead and go there next. All right, so now what I did is I put a second channel on can low. Red can high, green can low at the gateway module down there. Well, if you look, why they do this is, well, first off, that hash is wrong. Let's just get a good spot here. Okay, that's bad. It's all bad. That's our problem, obviously. But what it is it's a mirror image. So this goes high, this goes low. Can high, 2.5 volts to 1.5. Can low, 2.5 volts to 1.5. They twist them in a pair normally. I don't think the medium speed cans are twisted. I think they're just shielded. But what that does, it's redundancy. It's the difference between the two of the zeros and ones. So it's kind of like fault tolerant. If one voltage goes up on one for a spike, the other one will go up, but the difference is the same, or vice versa. That's why they do that on these CAN buses. Here's the issue though. Okay, first off, we don't have our 2.5 bias voltage on them. That we talked about earlier, but also that mess, that's all corrupt. That's all corrupt. Hence, that's why this is not working. And we got those U codes because the truck doesn't know what the hell that even means. So that is completely wrong. So if I turn off channel A, and there's just can low, look, can high spikes up. Can high spikes up. It's all corrupt. This truck doesn't know what the hell that even means. And our bias voltage should be right 2.5 volts. Should be up in here, but it's way down. And that message is completely corrupt. But what we saw is it's corrupt on, so when one, I want to see here, get this thing. It's doing it, it's affecting both can high, can low. Yeah, so it's affecting both, right? Completely wrong. Let me do a different time base here. Put a trigger on. Yeah, it's completely messed up. So what I want to do now, normally if this was shorted to ground, your voltage would be to 0. Or if we're shorted to positive, battery voltage would be to battery voltage. Or if we're shorted together, can high, can low would be 2.5 volts. We don't have none of that. Now, if you get a sawtooth pattern, it's like a loose connection or corrupt module. Obviously, I don't think all these modules are bad. I mean, there's no way they're all bad. It's either one bad module, or loose connection, or white, or termination resistance. So what I'm going to do next is check the actual termination resistance of the bus next. All right, so now I'm checking. I got termination resistance in the FCIM, 120. Termination resistance in the central gateway, 120. Should get 60. And I'm probing down there with the batteries unhooked, and I'm getting 120. So that tells me initially that I got an open, a term resistor that's not got another 120 in there. Maybe, maybe not. That's what it seems like. So what we're gonna do next is check each term resistor individually for 120. All right, I do wanna show you if I go across high-speed can 1, 6 and 14, because that's the term resistor, and the other one's on a different module, probably the ECM or something. We'd have to look at the chart. Well, guess what? I get my 60 ohms, plus or minus a few ohms. So that would be a good one, but that's not the bus we're on. Before we go any farther, I just want to show you that the windows don't work, radio don't work. Well, radio's starting to work a little bit, but the HVAC's not working. Sometimes it does, sometimes it doesn't. All right, so I took the gateway module with the DOC I'm at pins 22, 23. I should get 120, which I do. Now I'm going to do the same thing on the other end, because this is one term resistor, 120. I'm going to do the other one in the FCIM. I should get 120. And then across them, I should get 60. Let's do that next. So now I'm on the FCIM 17 and 18 right there, and we get 120 ohms. I would imagine we would have got 0, but we don't. We got two 120s, term resistor, term resistor. When you put them in parallel, you should get 60, which we don't have in parallel now. But I got the term resistor, and this guy's good. The term resistor, and this guy's good. And these are the terminate modules. But why don't I get 60 when they're hooked up? So what I'm going to do now is check wiring from this pin to this pin, continuity. However, it does go through other modules, and they're not term ones. We'll check that next. All right, so what I'm doing now, before my phone dies, I got to charge it. I'm on the gray and the orange, pin 17 on the FCIM. I'm on pin 23 on the central gateway module. I got 1.5 ohms. However, these other nodes, modules are still in the circuit, but that tells me we don't have an open wire, which I wouldn't expect. But that resistance is pretty good. Now we're going to check the other circuit next. Pin 18, violet and orange. Pin 22, violet and orange. Next. All right, so what I'm doing now is I'm checking, I don't know if I did this on film yet or not, the violet and orange, the can low, and the can low. I back probed it there. All right, well, my phone died again when I was filming that last part. So what I ended up doing is the can low wire from the gateway module to the FCIM module, that wire had like 50 million ohms, 30,000 ohms, 20,000 ohms, and then it went open, which, you know, with that much resistance is pretty much open. So what I did is I jumped the wire from the gateway module to the FCIM, and then I got my 60 ohms across the bus, because now it's continuing that circuit, and all my modules came back to life. The windows worked, the radio worked, the lights went off up front when you controlled them, and the heating, air conditioning controls worked. So that was wrong. That's what was wrong, was the can low line had a high resistance, had a short in it. So I ended up running a new wire, because it was a pain in the butt to find that behind the dash, and it was all wrapped up. And yeah, why would a 2018 vehicle have, you know, a wire that's that bad? But this guy lives out in the mountains here in Idaho, and you know, back on those cattle roads and all that stuff, and those mountain roads, it's going to have, you know, a bunch of vibrations and wear through. So again, we ran a new wire. Everything's good with this vehicle, but it's pretty cool to see it on the scope there. I did scope it afterwards. I just didn't get it on camera, but everything came back. The bias voltage came back, and everything was good to go. Communication was restored. So that is it for this video.